We'll now be standing by for the confirmation of second stage capture and the completion of this berthing process.
And Station Houston on 2, SSRMS mode to limp is complete. You are go for second stage capture. We will be uplinking the template commands on board, and the first template is there and ready for you to select confirm.
Okay, copy. First template's on board. Still got all 4 green RTLs, which is good, and I'm heading to step 5.2.
Copy and concur.
So with that call, the astronauts on board, Expedition 34 Commander Kevin Ford giving the go-ahead to move towards second stage capture. Following that, we will have completed the process, and Dragon will be successfully attached to the International Space Station. Second stage capture now in progress.
Houston 5.2.2 is complete and nominal. Ready for the next template.
And Kevin, the next template is on board, ready for your confirmation.
Okay, I'm heading to step 5.3.2.
Concur.
And Houston, 5.3 is complete. I got latches 1, 2, 3 shows 69 degrees, and latch 4 is at 71.
And Kevin, we copy and we see the same on the ground. We're going to hold at step 5.4 for a quick handover because we're going to have Radicom for the next 2.5 minutes.
Okay, copy that.
So standing by for just a minute or two while we wait to reacquire good audio communication with our astronauts on board the station. Expedition 34 Commander Kevin Ford continuing to work through with the CBM, and they continue to work towards that final second stage capture.
And Station Houston on 2, we're back with you after that handover, and the next template is on board. You are go for step 5.4.2.
I've got 4.2 coming up.
And Station Houston on 2, we see a good second stage capture. You are go for A-bolts in step 6.
Okay, I saw the same. It's going to be on down to step 6. They're all at 11 degrees, so here I go.
Again, there you just heard it, a successful second stage capture confirmed at 7:56 a.m. Central Time, while the station was flying just about 253 statute miles over the Arabian Sea. That coming just about 3 hours and 25 minutes after the successful grapple of Dragon by the Space Station's Canada arm a little bit earlier this morning. So with that second stage capture, Dragon confirmed in place and docked to the International Space Station at the Harmony node. Here's a short clip from a little bit earlier this morning of the capture. That capture again occurring at about 4:31 a.m. Central Time, while the station was just 253 statute miles over Ukraine. The capture done successfully by Commander Kevin Ford and Flight Engineer Tom Marshburn. So with that successful grapple earlier and the successful berthing just completed now, the crew will have a number of tasks ahead of them as they look to outfit the vestibule, or the connecting space between the Dragon spacecraft and the International Space Station. They'll be outfitting that with a number of cables in preparation for the upcoming hatch opening, which depending on whether or not the crew continues to work ahead of schedule may happen as early as this evening, or if not today, in the early hours of their day tomorrow morning. So again, just to recap the day's events, which kicked off in the early hours this morning at about 2:05 a.m. Central Time. Dragon was within the approach ellipsoid of the International Space Station, and integrated operations starting just a little while before that. Dragon successfully completed all of its height adjustment burns in the lead up to today's operations, with that final height adjustment burn 4, completing just about 13 minutes after 2 this morning. All of the laser rangefinders and thermal imagers on Dragon operating successfully as it approached the R bar, moving up towards the docking and capture attitude towards the International Space Station. Dragon completed all of its successful holds built in at 350 meters, 250 meters, and 30 meters. Departing that 30-meter part just after 4 a.m. Central Time, on its way to its final capture point hold, just about 10 meters away from the station. After arriving at that hold and going through one final go, no-go, Dragon team was given the go-ahead to enter into its final capture sequence. The team, the SpaceX team out in Hawthorne, California, controlling the spacecraft throughout. It arrived at its capture point and then grappled by the space station's robotic arm at 4:31 a.m. Central Time by Kevin Ford and Tom Marshburn, who were working inside of the station's cupola at the robotic workstation. Meanwhile, Chris Hadfield was monitoring the Dragon SpaceX on its approach. But again, that capture happening successfully at 4:31 a.m. Central Time. Following that, we stood by for the eventual berthing, which was conducted by the robotics controllers down here in Mission Control Houston. That second stage capture signaling the end of berthing, again taking place at 7:56 a.m. Central Time, while the station was just about 253 statute miles flying over the Arabian Sea. Here you can see the current station makeup with the Dragon attached to that Earth-facing side of Harmony. bringing an end to this flight up and delivering this next round of supplies for the Expedition 34 crew on board the station. The Dragon will remain docked for a number of weeks while the crew works to unload all of the cargo from the pressurized section. Also, robotics controllers will take another series of steps to unload some of the external cargo from the unpressurized section of the trunk portion of the Dragon spacecraft. All that coming up in the next few weeks during this docked mission of SpaceX CRS-2. So with that successful berthing of the Dragon spacecraft completed, we will be wrapping up all of our coverage today of the SpaceX Dragon's flight to the International Space Station. Our only programming note for you, be sure to tune in tomorrow for our resumption of Expedition 34 ISS update, where we will recap all of this morning and the weekend's events with the Dragon spacecraft, as well as giving you a look inside of some of the science and maintenance work going on board the International Space Station. So for now, thank you for following along as we track Dragon to its new home on board the International Space Station. But for now, we will go ahead and sign off. This is Mission Control Houston.
Space Launch System is the next newest, biggest rocket that we're going to build, and it's not just a replacement for the Space Shuttle. This rocket is going to carry us much further than the shuttle would go. It's NASA's next big rocket for deep space exploration.
The SLS is a national capability that provides a unique access to space that America has not had in 40 years.
A large launch vehicle like this really opens the door to destinations beyond. It's not limited by destination. It's only limited really by imagination.
What we're focused on here at this center is the propulsion system. And that consists of 2 solid rocket boosters and a core with some tanks that feed some liquid rocket engines in the middle. And then the astronauts sit on the top in the Orion spacecraft.
One of the things we recognized for SLS is we had to be affordable. So we had to do things differently, more efficiently, and smarter.
We're all conscious about saving money, doing it more affordable than we have in the past. But at the same time, we can't sacrifice reliability or safety.
The system uses a significant amount of heritage hardware, which is things that we've evolved from the Space Shuttle program.
The Space Shuttle had 2 kind of candle-looking things, which are the solid rockets. Those are kept, and those are used on SLS.
We've added a segment to the 4-segment solid rocket boosters that we had on shuttle. That gives it more power, more thrust, and it helps this larger rocket get off the ground. What those boosters are for is just to get you going. They burn for a couple of minutes, and then they fall to the ground. Then your liquid engines, you're up high enough, your liquid engines can carry your vehicle to as high as you want to go, and if you have additional stages, like we're going to have one, then you can go further out into space.
Right now, the inventory that we've got consists of 14 engines that have flown on shuttle. We've got 1 engine that was assembled and still needs green run testing or certification testing. We looked at all the spares. As we collected the spares, we determined that we could assemble a 16th engine. So we'll have 16 engines that we'll be able to use for flight.
We are making tremendous progress. We've got all of our prime contractors on board. We're testing engines, we're testing solid rocket boosters, our avionics systems.
J2X has recently set a record at Stennis. When we were testing, it was the first liquid oxygen engine to get to a full duration test in 4 tests.
We were developing this booster under the Ares program, and we're moving that into the SLS vehicle. The motor itself has been through 3 development firings, which are full-scale motors tested out in Utah, and we've gotten a lot of good data, engineering data from those tests.
This is an adapter that goes between the bottom of the Orion capsule and the top of the Space Launch System rocket that we're developing here at Marshall. It's been specifically designed to give strength to the adapter so that it can take the loads in flight and still be lightweight. This shape started out as a series of flat panels. The isogrid pattern was machined into the surfaces. Then they were formed, it was called in a process called bump forming, to make them into the shape that we need here. And we weld 3 of these segments together to form the cone that you see behind me.
We just delivered the first crew module to the O&C building at KSC. We started a lot of the parts onto the outside of the CM, and we've actually put it in what we call the bird cage, so we can locate all those parts, within, thousandths of an inch to make sure that everything is going together okay.
Putting, wiring inside of it, putting tubes for the, for the propulsion system, putting valves and pumps, and so all of that happens in stages right there in the O&C building.
We have on contract with USA, United Space Alliance, to build our harnesses. They're set up shop in the O&C, and so their little shop delivers to the big shop.
Thermal protection is very difficult in re-entry vehicles to test and to model. Really, you have to fly it to really understand what's going to happen. We're building ceramic thermal insulation tiles for the back shell of the capsule. We're building thermal barriers for the capsule, and we're building multi-layer insulation for that capsule.
I'm the heat shield design lead. So we're designing and building the heat shield for the future Orion missions.
The heat shield right now is in our big 20 by 20 router. It's a 5-axis router, and right now it's machining the interior bowl, if you will, of the heat shield.
To cut out that heat shield on the router, it could take weeks of machine time running multiple shifts.
It's the biggest heat shield ever constructed.
The other component is the heat shield skeleton, so that's the piece of the titanium substructure, the backbone that makes up the carrier structure itself.
Another unique thing is all the hand drilling that we're doing. So it's not automated by a router in this case, and it all has to be hand drilled by technicians on the inside.